In this video, we're going to learn how to maintain real anonymity and OPSEC on Linux, starting from basic concepts and slowly moving into more advanced stealth techniques. We'll walk through everything step by step, and you're going to see how a normal Kali Linux machine hardens itself and transforms into a fully anonymous operation system. To keep this clear and easy to follow, we're breaking the tutorial into 3 phases. Phase 1, System Stealth Mode. We silence the system, turn off noisy background services, and remove anything broadcasting our identity. The goal? Blend into the network instead of standing out. Phase 2, Identity Reset Engineering. We change who the machine is. New MAC address, new hostname, reduced fingerprint, cleaned logs, fresh identity every session. Phase 3, Network Cloaking. We hide traffic itself with VPN layers, proxy routing, and Tor circuits. After this stage, tracking becomes extremely difficult. All right, that's the map, so let's slide straight into Phase 1. This part is all about making the system quiet. A default Kali Linux install is kind of loud. It broadcasts Bluetooth, printer services, network discovery, modem info, and all sorts of small signals that reveal who you are on the network. We don't want that. We want to move like a ghost. So now we start shutting down anything that leaks identity. Let's go one by one. Disable Bluetooth. Bluetooth is constantly calling out, "Hey, I'm here, connect to me." We don't need that noise, so we shut it off using sudo systemctl disable bluetooth.service. Once disabled, the system stops broadcasting Bluetooth signals completely. Just like Bluetooth, we also disable cups using sudo systemctl disable cups.service. Even if you don't have a printer, it runs silently in the background. It leaks hostname, device details, sometimes even network info. So we shut it down the same way. Next is a Vahi daemon. This one is basically your system shouting across the network like, "Anybody out there? I'm available." Not good for anonymity. We disable it. No broadcasts, no discovery, no announcements. A silent machine is a safer machine. And finally, we disable Modem Manager. It handles broadband dongles, but if you're not using one, it's just another identity leak. Shutting it down keeps the system quieter, cleaner, and harder to trace. Your machine is now quieter. Less broadcast noise, less exposure, fewer signals leaving the system. Before we move to Phase 2, there's one more piece we need to understand: disposable network identity. You can have the most hardened system in the world, but if you keep connecting from your home Wi-Fi, you're still exposed. Your ISP can trace you. Your physical location gives you away, destined, not the machine. So a real stealth operator follows disposable network rules. Never use home IP. Prefer public Wi-Fi. Cafes, libraries, airports, crowded spaces. Use a hotspot or a SIM that isn't tied to your real identity. And never connect from the same physical place repeatedly. The more distance you put between you and your connection point, the harder it becomes to trace anything back to a real person. Now we move into Phase 2. Phase 2 is where we wipe the device identity clean and replace it with a brand new one. Your system can be silent but still traceable if it keeps the same MAC address, the same host name, the same browser fingerprint, and the same logs every time it boots. So Phase 2 is about destroying that fixed identity and rebuilding a fresh one every session. MAC address spoofing. Your MAC address is basically your laptop's license plate. Every Wi-Fi network you connect to logs it. So the first thing we do is install MAC Changer. It lets us swap that identity anytime we want. For that, we can use sudo apt install macchanger-y. Once it's installed, we bring Wi-Fi down using sudo ip-link set wlan 0 down. The network interface needs to be inactive for the operating system to safely reconfigure its hardware settings, preventing data corruption, connection drops, and ensuring the new MAC address takes effect correctly without conflicting with ongoing network traffic. If you're using Ethernet, replace wlan 0 with eth0. Now we generate a brand new MAC using sudo macchanger-r wlan 0. The -r flag stands for random. It gives us a fresh identity instantly. Then we bring Wi-Fi back up. After that, we verify it using ip-link show wlan 0. You'll see the permanent MAC and the new spoofed one. Permanent stays forever. The spoofed one is our temporary identity for this session. Right now, we're a whole new device. Hostname spoofing. Now we remove another fingerprint, the hostname. Every time your machine connects to a network, the hostname shows up in logs. If it says Kaylee or Parrot, that instantly tells people what you're running. First, we check what it is now using. Hostname. Here, mine is Kaylee. We replace it with something boring, something nobody ever cares about, using sudo hostname ctl set hostname. Here, we can set our hostname Windows update. Now confirm the change. Type again in terminal hostname. Now we look normal, not like a hacking machine. Browser fingerprint reduction. Even with the MAC and hostname changed, your browser can still snitch. It leaks screen size, time zone, fonts, hardware, all that info. To avoid this, we install Firefox ESR first, using sudo apt install firefox-esr-y. After installing, launch Firefox. In the search bar type, about :config. Hit accept the risk. Then in the search bar type, privacy.resist fingerprinting. Flip the toggle to true. Once that's done, our browser fingerprint shrinks big time. Final step, wipe logs and terminal history. If someone grabs this machine later, there's no commands, no pass, no trail, like you never existed. This is permanent. To delete logs, use following commands. Here, journalctl manages system logs, and vacuum time 1 second means only the last second of logs is kept, basically nothing. And to clear command history, use history-c for clears history from memory, and -w overwrites the file so nothing returns. Friends, our Phase 2 is complete. Phase 1 made the machine quiet. Phase 2 makes the machine new every session. We now have a fresh MAC identity, a spoofed hostname, reduced browser fingerprint, and we know how to delete logs or history after cooking something. We're not just hidden, we're disposable. Phase 3 is all about network cloaking. This is where we hide our entire traffic route. And the first step in this phase is the VPN layer. We start with a VPN, and we're installing Proton VPN, one of the most trusted VPNs out there, and one of the very few that actually offers a safe, free tier. Open your browser and search for protonvpn.com. Go to the download section, then choose Linux. Since we are on Kali, which is Debian-based, we scroll down and select the Debian-based Linux packages. You'll see a list of commands needed to install Proton VPN. Just run each command one by one in your terminal. Once the installation completes successfully, you can open the Proton VPN GUI with Proton VPN app. The GUI will open, and the first thing you need to do is sign in or create a new account if you don't already have one. After signing in, you'll see a list of available free servers. You can pick any server you want or just click Quick Connect to connect to the fastest one. After connecting, open your browser and check what is my IP. You'll see that your IP and location now show the VPN server you're connected to, not your real one. But keep this in mind. VPNs have a vulnerability called a DNS leak. Even with a VPN connected, DNS leaks can still happen. A DNS leak means your system is still asking your real ISP to resolve domain names, even though all your traffic is inside the VPN tunnel. Your IP address is hidden, but your DNS can still expose who your internet provider is. and that alone can link activity back to you. Proton VPN is good because it uses its own DNS servers, but never trust any VPN blindly. Always run multiple DNS leak tests using different tools. For example, open your browser and go to dnsleaktest.com. Run the extended test and wait for the results to load. If the results show DNS servers owned by Proton VPN and not your ISP, then you're safe. No leaks. Now we're going to see how to use proxies. But before we start, let's understand what a proxy actually is, what they are, and why we use them. A proxy is basically a middleman server. Instead of your device talking directly to a website, the proxy talks for you. So instead of you to website, we turn it into you to proxy, then website. And now the website never sees your real IP. It only sees the proxy's IP. Simple, clean, anonymous. But here's where it gets better. Instead of using one proxy, we can stack 3, 5, 10. Each hop hides the hop before it, meaning you to proxy 1, then proxy 2, then proxy 3 to website. If someone tries to trace it back, they don't hit you first. They hit the last proxy, then the one before that, then the one before that. And every extra hop makes you harder to follow. This is where anonymity stops being basic and starts feeling ghost-like. These are the main types of proxies we can use, and here's what each one actually means. HTTP proxy. This one is used mostly for basic browsing and websites. It's simple, but not very secure, and it can leak information if the connection isn't encrypted. HTTPS proxy. This is the safer version of an HTTP proxy because it uses encryption. It keeps your traffic protected, so it's generally recommended over a normal HTTP proxy. SOCKS 5 proxy. This one is the most flexible. It works with browsers, apps, tools, scanners, basically anything. That's why SOCKS 5 is considered the best option for hacking and operational security. Tor. SOCKS 5. This one gives deep anonymity because it routes your traffic through multiple encrypted Tor relays. It's rotating, layered, and extremely hard to trace back. Perfect when you need strong anonymity. To use proxy, we're using Proxychains. Proxychains is a popular tool that forces all our network traffic through proxies instead of going direct, meaning every request we make gets bounced through another server first. To install it, we just type sudo apt install proxychains 4-y. Now Proxychains is installed, but it won't route anything yet. We have to edit its configuration file first so it knows which proxy to use. Sudo nanospace /etc/proxychains4.conf. Inside this file, by default, strict chain is enabled and dynamic chain is commented out with a hash. Let's understand what these modes mean. Dynamic means Proxychains will try to use all proxies in the list. But if one proxy is down, it just skips it and keeps going. So even if one hop fails, the connection doesn't break. Traffic flows around it. This is the most stable and reliable mode for anonymity, which is why we use dynamic chain. Strict mode forces traffic through every proxy in the list in the exact order. If even one proxy fails, the whole connection stops. Strong, but very fragile. Random mode picks proxies in random order, sometimes fast, sometimes slow, sometimes unstable. Good for chaos, bad for consistency. What we want, dynamic chain. Inside the config file, we do this. Remove the hash to enable dynamic. Add a hash to disable strict chain. Now Proxychains will route traffic smoothly. No breaks, no failures, stable anonymity. Now scroll down and find the line, proxy DNS. This provides DNS leak protection. Make sure it has no hash in front. This sends DNS requests through the proxy too, so websites can't detect your real DNS resolver. For adding proxies, scroll further and you'll see the proxy format. When adding proxies, use protocol, then the proxy IP, port, and the username and password if needed. Protocol names must be lowercase, like SOCKS 4 or SOCKS 5. At the bottom, you will see the default Tor proxy entry, SOCKS 4 127.0.0.1 and port 9050. This works, but SOCKS 4 is old, limited, and does not support IPv6 or authentication. It leaks more metadata and is less secure than SOCKS 5, so we upgrade it to SOCKS 5. Now save and exit, Ctrl+X then Y and hit Enter. Now our Tor proxy configuration is complete. Now, before we use proxy chains with Tor, we need to make sure the Tor service is installed and running. To install Tor, run sudo apt install tor-y. After installation, start the Tor service using sudo systemctl start tor at default. To check if Tor is running properly, use sudo systemctl status tor default. If you see the status showing active running, that means Tor is up and running. To test it, run Firefox through Proxychains, Proxychains 4, Firefox-ESR. When Firefox opens, search https://check.torproject.org. If you see the message, "Congratulations, this browser is configured to use Tor," then your Proxychains plus Tor setup is successful. You're now anonymous through Tor, and all browser traffic is routed through Tor nodes. Remember, always place Proxychains before any command or browser to stay anonymous. For example, run Proxychains 4, curl https://api.ipify.org. Here you can see our IP address. It matches exactly what we saw on the Tor congratulations page. That means this IP belongs to a Tor exit node, and it confirms our traffic is being routed through the Tor proxy at 127.0.0.1. Adding multiple proxies, multi-hop. Now let's add multiple proxies. So routing becomes, you go to proxy 1, then proxy 2, then proxy 3, and so on, all the way up to N, and then finally to the website. Open the config file again and scroll to the bottom. Right below the Tor proxy entry, we'll add additional proxies. For this demo, we'll use some free proxies from spies.1. Quick warning, most free proxies do not work reliably. Some are dead, some reject connections, some throttle traffic, and some might work but are very slow. Paid or private proxies always give better performance and consistency. Copy a few proxies and paste them into the configuration file, using the proxy format we discussed earlier. Once you're done, save and exit. Ctrl-X, press Y, and hit Enter. To test the multi-hop routing, run Proxychains 4 curl-api.ipify.org. Here you can see our IP address showing the last proxy's IP. The traffic goes first through the Tor proxy, then through the proxies we added. If one proxy fails, it gets ignored, and the traffic automatically moves to the next working proxy. That's our dynamic chain routing in action. That's how multi-hop proxy chains works, layer by layer. Anytime you're using tools, always place Proxychains 4 before the command or the browser. For example, when we use nmap, we run Proxychains 4 nmap. The -st flag forces a full TCP connect scan. This is 100% proxy safe. The -pn flag disables ping. Ping can leak or fail when running over Tor or proxies, so we turn it off. Now every packet, every request is routed through the proxy chain. We're about to install the Tor browser, but first, here's why we use Tor instead of relying only on proxies. With proxy chains, the configuration can be perfect, but free proxies are unstable. They die, reject connections, drop out completely, and even when some work, they're often very slow. Tor is different. Tor gives us a massive built-in network of rotating relays. No hunting for IP addresses, no checking which proxy is alive. Tor handles everything automatically. Tor browser is also the most preferred browser among security researchers. It's specifically designed for proper anonymity and operational security. That's why our stack works. A VPN hides us from the ISP. Proxychains controls routing for tools. Tor browser provides stable, anonymous browsing. Together, they form a strong, layered anonymity setup. All right, now let's install the Tor browser, the secure, private, anonymous browser that keeps all your activity completely separate from your normal traffic. Tor browser doesn't come installed in Kali by default, but installing it is super easy. Just run sudo apt install tor browser -launcher-y. Once that finishes, launch it using Tor Browser Launcher. The launcher will automatically download the latest Tor browser and verify its cryptographic signature, making sure it hasn't been tampered with. This might take a minute depending on your internet speed. When Tor Browser opens for the first time, you'll see the Tor Network Settings window. Here, select Connect automatically, so Tor always builds a secure circuit when the browser starts. Before connecting, let's apply some basic safety settings. Go to the top right corner, click the three dots, and open Settings. On the left side, choose Privacy and Security. Scroll down until you see these options. Enable Block Dangerous and Deceptive Content, enable Block Dangerous Downloads, and enable Warn You about Unwanted and Uncommon Software. These settings protect you from phishing pages, malware downloads, and fake websites pretending to be legitimate. Next, scroll to the Security Level section. You can set it to Safer Mode. This reduces fingerprinting, blocks risky scripts, and tightens browser behavior while keeping most websites usable. Or, if you need maximum protection, set it to Safest Mode. This disables JavaScript on most sites, blocks advanced web features, and offers the highest level of anonymity. But some websites may break or not load fully. Choose based on your threat level. After applying the settings, click Save and restart the browser. This ensures all the changes take effect properly. When the browser reopens, Tor will establish the connection automatically. Open the browser and visit https://check.torproject.org. If you see the message, congratulations, this browser is configured to use Tor. Then your connection is officially anonymized and running through Tor's multi-layer relay network. Final warning, Tor browser is isolated for anonymity. Do not log into personal accounts, do not install plugins, do not change random settings, keep it clean, keep it simple, and keep your operational security tight. And if this video helped you understand real anonymity and OPSEC, make sure to subscribe to the channel. More advanced privacy, security, and real-world techniques are coming next.